All right, so we're going to compute some more principal values, principal roots. And so in example, in the first part A, we're looking for the principal cube root of I. Okay. Now, again, the rule for computing these is you take you put it in polar form, you take the nth root of the radius parameter, and then you take e to the I principal argument of z over n. That's the principal nth root. We know that there are n nth roots in general, provided you're not 0. This is just the principal one. Okay, so we want to compute the principal cube root of I. So to do this, we need the argument of I. The argument of I is pi over 2. We also need the modulus of I, which is our r, our radius parameter, is 1. And so what this tells us then is that z to the 1/3 is going to be r to the 1/3. E to the I argument of z is pi halves all over 3. 1 to the 1/3 is 1, so that doesn't really do anything. So this is e to the I pi over 6, which is cosine pi over 6 plus I sine pi over 6. And if you work out what that is, you should get 1/2. Oh no, you should get, sorry, that's the wrong order. You should get root 3 over 2 plus 1/2 I. So check that. So the principal cube root of I is root 3 over 2 plus 1/2 I. Or if you really like exponential form, you can just leave it like that. Either of those are fine. Great. Now let's do this next one. All right. So I think the radius is the easier of the two to compute. So let's compute that. So 1 squared plus root 3 squared under the square root. That's 1 plus 3 under the square root. That's the square root of 4 under the square root, which is 2. Great. And now what's the argument of 1 minus root 3i? Well, 1 and root 3 are part of a special triangle. Since it's 1 and root 3, it's the 30, 60, 90 triangle. Since the y value is bigger than the x value, it's a 60-degree angle that's formed. And since the real part's positive and the imaginary part's negative, it points downwards. So we should get negative 60 degrees, which is negative pi over 3. Okay, so from this, we then know that z to the 1/5 is going to be, we take our the principal fifth root of 1 minus root 3i is going to be, in fact, I don't even like that I've written this. Hang on, let me put an I here. And then here, instead of a z, I'm going to put a 1 minus root 3i. Is take the radius parameter to the 1/5 power. 2 to the 1/5 is a small number. And then we're going to take the principal argument, it's negative pi over 3, and we're going to divide by 5. So 2 to the 1/5, e to the negative I pi over 15. And cosine pi over 15, I'm not sure if there's a formula for it, it doesn't matter. This is a perfectly acceptable answer, so we're just going to leave it like this. And that is our fifth root of, our principal fifth root of 1 minus root 3i.